So the first question was an organic chemistry question, and it's all about crude oil. So it says crude oil contains many hydrocarbons and some information on the table about those hydrocarbons. You'll notice that they're all isomers. So we've got hexane, 3-methylpentane, 2,2-dimethylbutane. You can see I've just sketched up their skeletal formula. That's going to come in handy. We've got some boiling point information as well. So empirical formula of hexane, C6H14 is its molecular formula, but we need the simplest whole number ratio of the atoms, and that's obviously C3H7. Explain why hexane is both saturated and a hydrocarbon. There's two questions there. Saturated contains carbon-carbon single bonds, or you could say contains no carbon-carbon multiple bonds, so that's carbon-carbon double or triple. You could even say that carbon has its maximum amount of bonds around it. Hydrocarbon contains hydrogen and carbon only. If you miss out the word only, unfortunately, you don't get the mark. Skeletal formula for 2,2-dimethylbutane. So your continuous chain is 4, 1, 2, 3, 4, with methyl groups, 2 methyl groups on carbon number 2. So you could draw it like that or like that. Describe and explain the trend. So we've got to describe the trend. So I've got that there. We've got to explain the trend. I've got that down there. So let's just have a quick look at the table again. So hexane, look at its skeletal formula, 69, 63 for 3-methylpentane, 50 for 2,2-dimethylbutane. So try and get your head around what's happening there. So the trend is, as the amount of branching increases, the boiling point decreases. What's the explanation for that? The branched isomers have less points of contact or less surface contact than the unbranched isomers. And because of that, branched isomers have fewer or weaker intermolecular forces, which are called London forces between the molecules. So it's going to take less energy to separate the molecules from each other. And I'm trying to make it very, very clear that we are not breaking bonds. So when you boil these things, you're not pulling the carbons from each other and the hydrogens from the carbons. You're not doing that. Next part of the question, decane C10H22 can be cracked. What do we mean by cracking? We're breaking it down, breaking it apart to form hexane, C6H14, and one other product. So we're starting with C10H22. So we've got to make C6H14. Easiest way to do this is, how many carbons we got left? 4, because we had 10 to start with. We've got to have 6 in hexane. 22 hydrogens at the start. Well, there's 14 in hexane, and that leaves 8. So C4H8 was the other answer, or the other product. That's butene. You could have said 2 moles of ethene. That still balances. Your atoms must balance. And now a question about the reaction of butane with chlorine in the presence of UV radiation. So straight away, hopefully that's reminding you that it's radical substitution or free radical substitution. Substitution reactions involve something coming off and something going on. So hydrogen's going to come off, chlorine's going to come on. Now we're told we have to make the dihalogenoalkane product, Cl2. So we've got to take 2 hydrogens off, one at a time, and we're going to put 2 chlorines on. So those 2 hydrogens are going to combine with a chlorine atom, and they're going to form 2 moles of HCl. So there's the equation there. Complete the table below about 2 of the structural isomers of C. So now we've got to complete this table about 2 structural isomers of this dihalogenoalkane. So we're given the name of isomer 1, and we have to draw the displayed formula. So 1,4-dichlorobutane, there'd be 4 carbons in the continuous chain, chlorines at positions 1 and 4, and then we're given this one, So where are the chlorines? They're at 1 and 3. So this is 1,3-dichlorobutane. The reaction between butane and chlorine is an example of radical substitution. Initially, chlorobutane is formed, which then reacts with more chlorine to form the dihalogeno alkane. So the first step of the reaction of C4H9Cl with chlorine is homolytic fission of a chlorine molecule. What is meant by the term homolytic fission? So fission means the breaking of a covalent bond. So there was a mark for that. Homolytic is where you're breaking the covalent bond right down the middle, so each atom receives 1 electron from the bond. So you can either say that, or you can just say the making of 2 radicals. So breaking of a covalent bond producing 2 radicals, or the breaking of a covalent bond where 1 electron goes to each atom. Complete the missing species in the propagation steps below. So this much was given, and I've just written underneath a reminder that in any propagation step you have a radical reacting with a non-radical. So there's your radical, there's your non-radical. And another reminder, when chlorine radicals are involved in these reactions, they strip off hydrogen atoms to make HCl molecules. So that chlorine radical is going to strip out 1 hydrogen and form HCl. So the leftover, the remainder of that is going to be C4H8 now, Cl. So there's your other product. So that would be your new radical there. That then feeds into the second propagation step. That's going to react with a non-radical. So in this case it's chlorine, Cl2. And we're going to get the second chlorine combining with this. So we're going to get the product, C4H8Cl2. And that would be left over as a chlorine radical. And then the final part of this question, butane undergoes incomplete combustion when there is a shortage of oxygen. So you can see I've written above incomplete, just a reminder that CO is made. You can also make carbon if you want, or you can mix them and make carbon monoxide and carbon, but carbon monoxide only is the easiest, so I've gone for that. So C4H10 reacts with 9/2 moles of O2 to make 4 COs and 5 waters. Now imagine those balancing numbers aren't there. Now it's difficult if they're already there, but the way I balance them is I've got 4 carbons in the alkane, so I'm going to make 4 COs. I've got 10 hydrogens, so I'm going to make 5 H2Os, because 5 2s are 10. And then I just go and count up the oxygens on the right. So 4 plus 5 is 9. So 9/2 times 2 is 9, and that balances the oxygen.